This is a pretty straightforward geometric series question from C2. It's use of sigma notation here. Another key thing is it's asking for 3 significant figures, so we really don't want to throw away the last mark by not giving 3 significant figures. If you're kind of used to these things, you should see that the first term of this series is 6 and the common ratio is equal to 3. Okay, and it's perfectly okay to use the series formula Sn equals to a 1 minus r to the n, or 1 minus r, which is given in the formula book, or switch it because that can be useful, a little bit more convenient in cases where a is greater than 1, which it is here. However, let's just look quickly as to why this is a and this is a is 6 and r is 3. If we just pin this down a little bit, what this series is saying is the first term from this rule here is equal to 2 times 3 to the 1. So that's 6. That's how we've got the a is equal to 6. And then u2, we have 2 times 3 squared, which is 18. And u3, we've got 2 times 3 cubed, which is 54. And you see that they're going up in a common ratio of 3. So that's how it works. Okay, so that's how the thing works. That's how we know. Incidentally, we should see that the common ratio is 3 from the 3 there. That's the common ratio, because that, when it's written in that way, always gives us the thing that's to the power of r. Remember, r here is the counting r associated with the sigma. That bit inside that inside the power is will always be the common ratio when we're looking at the UN rule, or we're looking at sigma notation. So that's pretty. So let's just get on with it now. So we can just say the required sum 20 to 1 of 2, 3r is equal to, I'm going to use this version of it, 6 times by 3 to the power 20 minus 1 over 3 minus 1. And what we see is this cancels with this to give us 2. So it's 2 times 3 to the 20 minus 1. And that makes it equal to, when we work that out, if we're going to quote 3 significant figures, as we should do, because it's asked for 3 significant figures, probably best to go for 3 significant figures anyway in these questions, but if it's asked for it, we definitely need 3 significant figures. So it's 1.05 times 10 to the 10. Okay, it gets very large quite quickly because it's geometric with relative, with a common ratio of 3, which means every term is tripling. That's going to get pretty big, pretty quickly. So that seems like that's the answer. Okay, part B, just testing whether we can use the S infinity formula and do a little bit of simple algebra after that point. We're just putting things in there. It may seem a little bit counterintuitive that the first term here is greater than the sum to an infinite number of terms. It can happen. When it does happen, r will not only be less than 1 and greater than minus 1, but it'll actually be negative. So in other words, it'll be between 0 and minus 1. If we have a situation like that, then we can have such a thing where the first term is actually less than the sum to infinity, as we do here. So we have 8 is equal to 12 over 1 minus r. If I multiply that out, I get 8 times 1 minus r equals 12. Multiply out the bracket. So we have minus 8r equals 4. So r equals minus a half. There you go. So that is it. That's the question done. And as I say,